Let me ask you this. How many times you wasted hours digging through PDFs, reports, or policies just to find out one simple piece of information? Frustrating, right? Now imagine if instead you could just ask a question and get an answer instantly. That's exactly what we are going to build today. A custom AI assistant that understands your document. So here's the big idea. It's called Retrieval-Augmented Generation, RAG. Don't worry, sounds fancier than it is. Let's break it down into three simple steps. First is the retrieve. So we search through our knowledge base to pull out the most relevant information. We call it as chunks. Then the augmentation. Then we take that info and inject into the AI prompt, basically giving it context so it knows what we are asking about. And generate is finally the AI crafts a response. But here's a catch. It only uses the context we gave it. That's why the answers are accurate and grounded. And to manage all the moving parts, we are using LangChain, which is a framework. Think it as a glue holding everything together, be it models, data, APIs, all in one place. And if you want to get more advanced later, there's a LangGraph, which lets us build workflows that aren't straightforward, but dynamic graphs. Pretty cool, right? So now where we are heading. So we are in phase one. So we'll divide the complete structure into three phases. So in phase one, we would be building a simple RAG MVP. It can handle one document at a time, just proof of concept. In phase two, we'll add persistence and memory. Imagine uploading doc today, coming back next week, and the assistant still remembers it. And in phase three, we'll go big, multi-source integration, not just PDF, but email, database, even websites. Basically, your own personalized knowledge assistant. Let's test this live with a demo. To prove that this work, I created a completely fictional story using Gemini. It's called The Legend of Devi Ananta. Here's a catch. The goddess doesn't exist in any mythology and no AI model knows about her. The only place this story exists is in this PDF I generated. So here's a short excerpt. So from the heart of blooming lotus arose goddess of serene power. She has four arms, each representing four pillars of universe, creation, perseverance, destruction, and sustenance. She was named Devi Ananta, the boundless one. So now if I ask a very normal model about her, it would either say I don't know or just make up something. But when I upload the PDF into RAG system, the assistant can answer perfectly because it retrieves it directly from the document. Now let's see in action. So this is how the UI looks like. I'll upload this document. Um it's right here. I'll upload it. Upon clicking the upload PDF, it is getting processed, chunked, and stored in FAST. Now let me ask this question to RAG. Yeah, how many arms Devi Ananta has? Let me copy this name. How many arms does Ananta has? Okay, straight away it returns. Devi Ananta has four arms. Let's try something more. So in her first hand, she held a shimmering serpent. Let's see what she held in her first hand. See that? It pulls out exact details, the forearms, the serpent, the lotus, everything. That's the power of RAG. It grounds the AI in your data, no matter how obscure or it new it is. So now let's see how HLD looks like. Okay. So at top we have user interaction layer. Upload a PDF, we saw it. Ask question, we saw it, and fetch a response. Right. So underneath is a Flask API with two main endpoints slash upload PDF and slash chat. The upload PDF handles the document ingestion portion. The chat portion processes the question and retrieves the answer. The real magic happens in the RAG pipeline. So my in this PyMU PDF loader extract text from PDF. It Once the PDF is loaded, we use recursive character text splitter. So this chunks the text. Next, the splitted text is passed into the OpenAI embedding, which converts chunk into the vector. And this vector is something that we are persisting in the FastDB. So when a question comes in the pipeline, we embed the query, searches the fast, retrieve the best chunk, send them with the question to GPT-4o. So this is the retrieval flow if we see. So don't worry, we'll dive into the actual code in just a moment. Let's get started with the actual code. If you see, we have structured the code into backend and the front-end folders. The front-end comprises of the simple React application, nothing fancy there. But in backend folder, if you see, we have created our APIs that resides inside routes.pdf. So this route.pdf contains the upload portion for that. We upload the PDF, we create a temporary file in memory file, and then we start processing it. If you see the code, we uses the PyMU PDF loader that loads the PDF. Then we split using the recursive character text splitter. Notice the chunk size and chunk overlap here. So keeping the chunk size right is very important. If we keep it very large, this can be problematic. A large chunk might contain too much irrelevant information, thus diluting the key facts and making it harder to retrieve system to find the correct context. And very small chunk size, this can lead to loss of context. So in a sentence or paragraph broken up into tiny fragments, meaning the meaning can be lost, right? Uh, then we used OpenAI embeddings that converts into the vectors, and finally we are using in-memory FastDB. So we are storing all the document and that embedding in that vector store. Now comes the second portion of it regarding the chat part. So we'll see routes.chat. So this is a /chat endpoint that is being used here. So this is the method query RAG pipeline. So first, it performs a similarity search to retrieve the document chunks. So whatever query you have provided, it does a semantic search on it. Once we have done the semantic search, we go to chat OpenAI, and we provide a template that you are an AI assistant, and you the following and you have the following context, and you need to answer something. So we provide the context and the question, and then we just create this load QA chain that is a LangChain provided uh, in an abstracted method that would do all the question and answer for you. And chain type stuff means that we would be providing the complete context as a big single block. And there are other chain type also, like map reduce, wherein if we have lots of documents, which we see in phase 2 and phase 3, we'll use those type of chain type. But for the phase 1 MVP, this is quite straightforward, and we can go ahead with this. Once we have everything, we'll send it this document and the query to the OpenAI, and it is going to return us the response, right? So this is all about. Before we wrap up, let's zoom out and think about where this can actually be helpful. Uh, so corporate knowledge is one piece wherein new hires can quickly find answers from HR policies or technical documents instead of bugging their teammates. In education and training, students can interact with textbooks, lecture notes, or manuals as if they are chatting with the tutor. In product management, ingest research report or feedback surveys and get instant summaries or complex insights. Anywhere there's a mountain of unstructured data, RAG turns it into something usable and interactive. And remember, what we built today is only the phase 1 with persistence, memory, and multi-source integration. We are on the path to create a true intelligent knowledge assistant. If you'd like to explore this further, The complete code is available in the Git repo. You can just follow me. You can just follow me with the push testing. I post in lots of other use cases. Uh, I'll I'll share the link of this repo in the description block. And if you like to explore some more content that I have written, it's there in my blog site. You can just go and visit some interesting POCs. So thanks for joining me in this session. I hope this inspired you to start building your own RAG-powered assistant. This is just the beginning. Let's keep exploring together.